Ugh. Okay. Are we started? Oh, is it go? Yeah, okay. Okay. All right, I guess I'll stand up. Yeah. Okay. Oh. All right. When I say inverse, where are my teach students from last year? When I say inverse, you say where's another one? Is there another one around here? Who do I have? When I say inverse, you say what is happening? When I say inverse, do you say three people don't remember switch X and Y. Oh my goodness. What do you got there? What is that? That looks like not my class. Reading a book during math? What? All right. So that's what inverse is. When I say inverse, you say switch X. Actually, Mrs. Cooper likes domain. You remember this part or no? Domain and what's the other thing? Range, and then the word rhymes. Domain and range. X change. All right. Domain and range exchange. Okay, so reading, great. I'm not besmirching all those words. You can read those. That's kind of like if you were absent. You could just read the notes there, and it's basically the things that I just said there. So it says I want to find the inverse of this line. So you know what you could do? This is how you find the inverse of a graph. You get points like 4 comma 0, 0 comma -1. Yeah, okay, I'm trying to think ahead of time what's going to happen so these points aren't in the way. And then this is 1, 2, 3, -4, -2. I think it'd be smart to put it up here. Okay, and then let's do this again. Apparently, I didn't say this enough last year. When I say inverse, you say switch X and Y. All right, and then that becomes -2 comma -4, 3, 4. This becomes not 0, -1, -1, 0. And then this becomes not 4, 0, 0. Did I just do something wrong there? Something's wrong. 0, -1 becomes -1, 0. All right, and then, no, I guess I'm good. 4, 0 becomes 0, comma 1, 2, 3, 4. Okay, good. I didn't think that created a line. And then there's the inverse of, is that called f of x? Yeah. So this would be called, oh, and then this bears noting. If I say find f to the -1st of x, you need to know that that means inverse, and therefore means switch x and y and so on and so forth. I'm going to do the next one before I make a thing that you should remember from last year point. Yeah, input, say it. Output. So yes, that is 2. 2 minus 2 is 0. Square root of 0 is 0. And then this is 3. Well, wait. 3 minus 2 is 1. Square root of 1 is 1. This is when I found out we had problems last year. Input, say it. Yeah, the bums that would say it but couldn't do it. Couldn't literally graph this simple graph by just throwing in values for x and getting y's. I was scared at that point. What happened to you mathematically in your life if you're not able to do this? 1, 2, 6. 6. Why would I plug in 6? Because 6 minus 2 is 4. What's the square root of 4? 2. And then this goes on. This could go on forever. What would be the next one? 9. So I think I'd have to plug in 11, right, to get 9. Now, all those other ones work. That's why you draw a curve. You can take the square root of 4 minus square root of 2. 4 minus 2 is 2. Square root of 2 is a decimal. So you know what that decimal is? Somewhere around there. There are other points other than the ones. We just want to get easy points to graph this, right? But I don't want that one. I'm not going to invert that point. Okay, when I say inverse, you say switch x and y. You know what? That's 2, 0. The inverse of that is 0, 2. This is 3, 1. I don't want to have to write it. This is 1, 3. I think that I just went too long last hour. 6 comma 2 becomes 2 comma 1, 2, 3. Oh, I like this grid actually with these by 5s extra lines. It's nice. I have not seen that in a while anyway. Okay, and now here's a connection. Here's a connection we can make. And this is true, and I think it's written in the notes somewhere. That is called the y equals x line. Get ready. I don't think I've done this too often this year. The reflection sound. People that had me last year, well, they don't remember anything. So anyway, so there's going to be a relationship told to you somewhere, or I'll tell you now. Graphs of inverses are reflections over the y equals x line. This is another relationship. Did that work over here? Absolutely. I don't know why that's happening. Okay, draw this line, and good. I like these boxes here, these extra ones. Here we go. See that? Reflections over the y equals x lines. Okay, all right. Good enough. And then I think this is what they, read that. That's fine. Definition of inverses. Go for it. It's good. It's good. It's good. Okay, input, say it. Output. So we can fill in this chart. -2, comma. 2 times -2 is -4. -4 plus 8, right? -2 plus 8 is 6. Oh, then you know what? We have a slope of 2. So I bet you this is 8, 10, 12, right? But you know what? You know what the deal is with a line? A line, what's the domain of a line except if it's vertical? All real numbers. Should be doing the double R more because what's the range? No, I mean look at this. Look at any line unless it's vertical or horizontal. Horizontal would be a problem. What are the ranges of both of these lines? What Y's do they cover? All real numbers. Okay, so you're not really going to see anything special here. All right. Why am I going to choose to do this for input? Say it. You know what? I'm randomly going to choose 4. What? Why would you do that? Look at the other chart. What's 4 minus 8? -4. What's -4 divided by 2? Look at the other chart. 6. 6 minus 8 is -2. -2 divided by 2 is -1. Look at the other chart. 8. 8 minus 8 is 0. 0 over 2. Look at the other chart. 10. 10 minus 2. 2 divided by 2. Look at the other chart. Stop telling me to do that. 12 minus 8 is 4. 4 divided by 2. Look at the... Shut up. All right. So nothing really special happens here. So yeah, we're going to go on and talk about a connection about domain and range exchange. But that really did kind of happen. The domain of this is the range of this, and the range of this is the domain of that, but you don't really see that sticking out. You know, it doesn't really do much for you. So we do have to know this then. If f of x has a domain of this and a range of this, then the inverse of f of x has a domain of the range of the original. And the range is the domain of the original. Okay, it didn't really show out though in that last one. We'll make that connection here, actually on this one. But I did do this with these. You know what? I think I'm going to just make a new grid. No, I guess. I really wish I had a blank graph here. Not complaining about their notes. They're always awesome. They always try to make all the connections that you need to make. Okay, and then, you know, I want to pull out some points that I can see are happening, like those two, right? That should be enough to see what the inverse is. All the other ones don't really, I guess I could make up one here and here. I didn't do that with the other hour. I can make up decimals and then flip those, and then it shows asymptotic behavior. And maybe I will do that once I flip these. So this is 3, 2. Now you're at 2, 3. 1, 2, 3. The other class, I put the graph right on top of here, and it looks messy. I don't know. I guess I could have, but whatever. And then this is 4, 1. Now it's 1, 4. Okay, it seems like we're approaching something here. Like let's make up something here. Like this is 8, a half. Let's say. Let's make it up. 8, a half, right around there. So that's a half, 8. Oh, okay. So actually, it looks like my asymptotic behavior is now vertical. So I will make this comment right now, or a question, and then no one will answer probably. what do you think the inverse of a horizontal line is? What's the inverse of a horizontal line? 3, 2, 1, go. Vertical. That's why that y equals 0. This was y equals 0. Now is x equals 0. Domain and range exchange. You know, that's really another way of looking at that. I better stop though. Well, I could also do this. This is like, what? Why do these things happen in the stupid computer program thing? All right, anyway, this is 2 point, like let's say 2.1 comma 5, 2.1 comma 5. I'm making this up. It's close, right? 2.1 comma up, maybe right around 5. Now that's 5 comma 2.1. So it looks like I'm approaching 2 over here. You know why? What's this vertical asymptote? X equals, anyone? 2. So now what's the horizontal asymptote? Y equals 2. So I'm getting that behavior switched, exchanged. All right. And that's another way of looking at this. All right. All right. And then I don't have to be so big deal about that. I could just take 0, -1 and make that -1, 0. Then another one looks like 1 comma -2. So -2 comma 1. I think those points with the asymptotes are enough. So there's the inverse of that. The real big deal is this, the changing of the asymptotes. So the domain of the original was everything but, sorry about, doing 2 pages on one side, but it fits in there, and I saved how many pieces of paper? 38 times 2, 76 pieces of paper today. Congratulations, Mr. Samuels. Right? Not 2, correct? The domain. Well, look at the range of the new one. Not 2, because that's where the horizontal asymptote is. So now we really see that domain and range exchange. All right. Anyway. And then the range of the original was not 0. I'm saying it like inequality wise. And then the domain of the new is not 0. So domain and range exchange. Right? You know how they write that with the x element r? X element r, that would be for this one, except 0. I've seen that before on the AP exam. All right. I had someone ask me during a test, and that was actually the one time I was nice that he answered a question on the test. What is this ER thing? They've never seen that before. And the only reason I answered is I'm not really sure I ever wrote it in class. They only would have experienced it on the AP exam. So. All right, graph these 2 functions on the same axes. Input, say it. This is what I knew we had some problems last year. You'd say it, but some people couldn't graph it. And you'd have to graph these by hand without a graphing calculator. And like 5 students in class couldn't function mathematically. And I'm like, you're in an honors course, man. Input, say it. If you can't input, output, you don't belong in here. 0 cubed is 0, plus 1 is 1. 1 cubed is 1, 1 plus 1 is 2. You're going too fast. No, I'm not. You got to be mathematically structured. 2 cubed is 8 plus 1. Why is he so mean? I don't know. It's Thursday. It's been a long week. I got shushed in a math meeting yesterday. I'm a little cranky right now. All right. -1 cubed is -1. -1 plus 1 is 0. And then -2 cubed is -8. -8 plus 1 is 7. All right. Oh, I didn't graph. Okay, so then that's when you learned what a cube graph looks like. I think we did do that in first semester. Then we wrapped all the way around into second semester, end of the year, and did cubics again. Yeah. All right, and then input, say it. I input 1. Yes, that's the first point you plug in. You want to locate the 0 value. And then that's 0. So 1 comma 0. Hey, no. Oh, no, I want this green. You know what? I'm going to go ahead and draw this right now. The y equals x line. They're proving it again. This whole y equals x thing. in graphing these. All right. And then I plugged in 1, so 2. 2 minus 1 is 1. Cube root of 1 is 1. So 2 comma 1. Ah! It's supposed to be green. And then, the next one that's nice is 9. Because what's 9 minus 1? 8. What's the cube root of 8? So it's 9 comma 2. And that's when you got this part of the graph. It's actually just a little bit, it's flatter than the other one. It doesn't take off as quick. Because cube root is like, makes numbers smaller. And then you plug in 0. Yeah, you can take the cube root of -1. That's not an I number if you're thinking that. No. -1 times -1 times -1 is -1. That works. So the cube root of -1 is -1. Next nice one is -7, because -7 minus 1 is -8. Cube root of -8 is -2. Ooh, and I did that quite perfect. That point right there is right on the y equals x line. And then here we go. Let's go purple and do our noise. Okay. Remember this now? Didn't remember switch X and Y. All right. Okay, you can read. Yeah. And then we're actually going to do this. Find the inverses and then talk about a few things. Okay. So when I say inverse, you say what? Switch X and Y. Ooh, she even wrote it there. All right. So we're going to go ahead and follow those notations. Okay. So X equals 3y minus 5. So that's the switching of the X and Y. And then you resolve. 3y equals X plus 5. And then, you know what? You could divide by 3. And you can almost leave it like that. But what you need to do is turn it into inverse notation. Remember what I said, I think, at the beginning? You need to know what that means. Find f to the -1 of x. You need to know that that means inverse. If you come up to my desk and test, what does this mean? I'm going to say, sit down that time, because that's part of your test, knowing the mathematical language. You'd either leave it like this or write it as x over 3 plus 5 over 3. Okay, and then it's nothing special. What's the domain and range of a line always? All real numbers, except if it was vertical or horizontal. The range is would be just one number if it was horizontal. Okay, so nothing really special there. And then nothing really special here on domain and range. You know what? Let's just do this. All of these go all right here. Okay, because the domain of and range of a cubed, we just graphed a cubed, guys. We just graphed, that's the red one. Fumble. By the way, the domain and range of a cubed root is the same, except, it just takes longer for the y's to get covered, right? That is very a flatter graph, but it still is. Okay, and then we'll prove it. When I say inverse, you say X and Y. So this is X, this is Y. And then, well, the only thing to do is cube. Got to cube first before I start moving numbers around. And then we can go ahead and write this in inverse notation. What am I doing? It's not cubing. What do I have to do? Sorry, my bad, dogs. Ruff. That's what I get for not whatever I do to one side, say it. I didn't write that, so I was writing cube instead of cube root. Oh my goodness, so embarrassing. Okay, and then I have to subtract 2. So it's the cube root of x minus 2. Okay, and there are no issues if the domain and range of the original is all real numbers, and then that would be the same for the inverse. Nothing special going on. Okay, everyone all right so far? Not exciting. Low energy day. It's gloomy outside. It's been gloomy for 2 days. See that? All right, and I just covered this. What's the domain and range of a cube roots? We just graphed it in green. What's the answer? Real numbers. X, E, R, Y, E, R. And that's going to happen. Actually, what I should do is this. Yoink, yoink. but that would be y, and that would be x. That is really what happens, but it doesn't matter. It's all real numbers, right? But we should say x here, not y. You know, you get it. Just all real numbers, all real numbers. Okay, and then switching x and y. Yoink. Just simple math here. X equals -2 cube root y plus 3. Subtract 3. And then this is what I was yammering about. What do I have to do here? I have to divide by -2. All right, and then how do I get rid of a cube root? What do I do, everyone? Cube it. So if this was written, we found that they don't care if you just leave this like this. We found that out at the end of the year last year when we were building up to the AP exam. Although this is like -1/2 times this. I'm trying to sneak that negative in there. So to cube that, this could be written as, and I do want to change this notation. This is an option for you. What's -2 cubed? -8. Or we could, write this as -8, and then it's x minus 3 cubed. It's an option. You don't have to do that according to AP, like clean this up. Okay, but really the thing is a cubic, it's going to be upside down compared to the regular, but it's still going to be all real numbers for both domain and range. It doesn't really matter, and they don't ask you to graph it to make connections, so we can move on. Okay, now this is where it gets special. Input, say it. Well, what's the domain? Well, let's think about input output first, then we'll come up with it. Can I plug in -2? No? Oh, why did I pick that? Can I plug in? No, I guess that's a good. Are you sleeping? Were you? Are you sure? Okay. What are you doing? Are you still eating? Is that why you're covering your mouth? Okay, hands in the air. All right, good. This is all in the video. Are you all right? You make these faces sometimes. Okay, can I plug in -1? Yes. What's -1 plus 1? What's the square root of 0? What's 0 times 3? What's 0 minus 2? So -2, sorry. So -1, -2. We this was like in the end of August or early September last year. This is when I knew we had some problems in my class. 0 plus 1 is 1. What's the square root of 1? What's the square root of 1? 1 times 3? 3 minus 2? So 0, 1. Next nice one would be 3. Why? 3 plus 1 is what? Square root of 4, 2. 2 times 3, what? 6 minus 2, what? So I plugged in 3, and I got 4, right? Is that right? Yeah? And then maybe one more. Because when I say inverse, you say, which x and y? All right. No, that's it. Whoa, I'm struggling. 8, right. What's 8 plus 1? 9. Square root of 9, 3. 3 times 3? 9 minus 2? So 1, 2, 3, 4, 5, 6, 7, 8. I plugged in 8. I got 1, 2, 3, 5, 6, 7. What you come to find is actually a square root function is really half of a parabola going right. It really is. So it's half of a parabola going right. If I drew the other half, oh, I forgot to do this. And I did stop the notes at this point to because I just saw 1 to 1. And I put this at the top of the notes here. You could put it wherever you want. First of all, one of the very beginning things that we talked about last year is what is a function? And I gave you the simplest direct definition ever. A function is just a relation that has absolutely, positively no repeating x's. Wrong. So you notice when I said that it's a parabola that goes like this, that was the square root function, right? If I had plus minus in front of that square root function, this is what I would have. What does this graph fail? What is that called? Vertical line test. You want to know why it fails it? It's because that means I have a 2 time and no good x value. I have x comma this and x comma that. The same x value has 2 y's. So therefore I have a repeating x. This is not a function, right? Remember that? So What's a one-to-one function? I'm not writing out the words like I did last year. What's a one-to-one function? Okay, this didn't go well last hour. It's a function with no, anyone? When do you want to finish this sentence? No repeating what? Y's. There you go, right. Okay, no repeating y's. Is this one-to-one? A parabola going up? Is this one-to-one? No, you know what this fails? The horizontal line test. So this is an example of not being one-to-one. Got it? So those are both anti-examples. Okay, so those are the most simple definitions. I remember hating the domain, the function definition when I was in high school. I confused no repeating x's, no repeating y. What's the point? And blah, blah, blah. You know, I didn't like it. Okay, so state the domain and range. Okay, now we can do that. What's the domain? Well, what was I allowed to plug in first, everyone? What number did I plug in first input? Nobody answered. We got no time for this. Ain't nobody got time for that. And then what's the range? Well, look at the first y value that happens. What number is that? -2 to infinity and beyond. He knows the movie. All right, so is this function one-to-one? Yes. Okay, so yes. And there's a point to this too. And actually, I do have to do an explanation of a function that's not one-to-one, what we have to do. Okay, but anyway, find the inverse of this function. Fine, finally got to it. X equals 3 times the square root of y plus 1 minus 2. All right, so we can add to. This is where it gets a little wonky. You know, what do I do with this divide by 3? You could leave it. So it's y plus 1 square roots. And then this is x, sorry. This is, it's going to look funny there. X plus 2. You could leave it like this, divided by 3, and then square both sides. And then quite honestly, you could leave this like this. You're allowed. You could leave this as x plus 2 over 3 squared, and then minus 1. Because I freed this, so these canceled, and then I subtracted 1. Right? And that's actually, they allow it. The only thing you could do is square that 3. So it'd be x plus 2 squared all over 9. You know, you could write it like that. I think it's fine. All right, so graph the inverses on the same axis. All right, input, say it. Well, really, what I could do is this and then just check. -1, -2 is now -2, comma, -1. Look, -2 plus 2 is 0. 0 over 3, 0 squared, minus 1 is -1. But wait a minute, I just realized something. Isn't a parabola like this? Isn't that what a parabola should look like, right? Let's switch all these. 0, comma 1 is 1, comma 0. This is 1, 2, 3, 4, or 3. Sorry, 3, comma 4 is now 4, comma 3. Let's check that. 4 plus 2 is 6. 6 divided by 3 is 2. 2 squared is 4. 4 minus 1 is 3. Input, output. It worked. And then I believe this was 8, 7. Now it's 7, 8. Gotta move up a little bit. All right? But all I get when I switch these points is this. And that's the idea here. The domain and range of the inverse must be the range and domain of the original. Otherwise, you will get too much of a picture. You'll get a picture that's not one-to-one. This is a function, the red one, so I do get a one-to-one. And it's one-to-one, so I do get a function when I invert it. I got my words correct there now. Okay, so what's the domain and range? Even though the domain of this is all real numbers, this part never gets graphed because of where it came from. So the domain is actually the range of the original, not all real numbers. And that's leading to what we call restricting a domain if it happens in reverse. All right, now I'm going to do that real quick. Whether you're bored by it or not, I couldn't care less. All right, because we had this last year and we had to do this. What if I had another example? You stick this wherever you want. What if it was just I did this, y equals x? I didn't do it all the way through. I didn't even find the inverse, but I wanted to make a point about something. And I did want to do it in vertex form so it could be nice and easy. You should know that this is a vertex of 1, 2. I believe we did that even this year, and you did it last year. And then you should know that the graph looks like this, yoink and yoink. What is this function? Not what? Not what? 1 to 1. So what happens when I find the inverse is I will not have a function. And for some reason, mathematicians can't stand that. They go crazy. They go bonkers. All right? So what you got to do is what's called restricting the domain. You got to cut that part off so that only this part ends up resulting in the finding the inverse of it. Right? And that's actually what would happen just knowing about y equals x symmetry. Oh, I didn't do that. Okay, I know the kids enjoy it. Shannon, say it. Shannon, there's the Shannon. Because that's why I know that this is kind of what the graph looks like. All right. Also, I know a little bit more. So you would have to restrict this domain to be from only 1 to infinity so that you would only get this part so that when I invert it, I do have a function. All right. And that was something that we did have last year. That's all I really want to cover about that. I don't want to go all the way through it. Looks like some people are almost dying in boredom. So I'm going to move on. Are you okay? Okay. All right. All right. Now, this is a true statement. This is a tie into yesterday now, too. For functions to be inverses, this is brand new information. Or is it? Didn't we do this last year? To prove two functions were inverses, f of g of x equals x. And then when you flip it around, g of f of x equals x. Both would work. Okay, so they're saying let these be functions. Show, that means that they are inverses. Show that they are inverses, and we're going to add this in the directions so that you specifically show that work. You're going to show every algebra step, any skipped algebra steps, then Fat Thor will raise his red pen up in the air and grab lightning and destroy your test with red marks. If you don't, show all your work. So here we go. Are you okay over here? All right. G of x. So 1/2 x plus 3/2. Okay, so that's the first step. Replace g of x with its functional value. And then wherever there's an x, I'm going to replace. Oh, this looks tough. We got fractions. All right. 2 times, all right, 1/2 x plus 3/2, and then minus 3. And then we'll help the kids with the little highlighter there, showing that replacement. Okay. Now, when you distribute 2, 2 times 1/2 is x. 2 times 3/2 is 3. X minus 3 plus 3 equals x. And you do this. You say, check baby, 1, 2, 3. It showed up. What should happen? All right. You should get x when you're done. You're not done, though. Unfortunately, you also have to do g of f of x. And I'll let this kind of leak. Go a little bit below here, and then move to up here. So what's g? I could use a highlighter for that. In the g function, I want to throw in 2x minus 3 in that spot. Okay, and then we go ahead and do that. 1/2, 2x minus 3, and then plus 3/2. Wait a minute. Oh, half of 2x is x. Half of 3 minus is minus 3/2. Okay, it all works out. Feel free to do this and maybe say, check, I got an x and I'm good. So may not have, know why, but this is exactly what happens. And then look at what they say here. Here's the reason. Where x is greater than or equal to 10, that's because this, it's actually because of this domain, really. All right, that domain. That's what the domain of this is, which affects the range of this one. But also you'd have to limit your, the range of this one would be the domain of this one, so we have that restriction again. But don't worry about it. It's not what this question's about. The question is about proving. So you got to do this algebra. Almost done. What time is it? You always get excited when you look at that. What is it? 42. What do we get out? 55? Okay. Hopefully I'll be sitting by 50. We'll see, though. Oh, what? I got confused. I used the wrong letters, right? Doink, doink, doink. Okay, h of k. Ooh, I don't like k. It looks too much like x. H, mine does anyway. Square roots of x minus 10. And then highlight for notes purposes. And then, okay, well then the next thing is square root of x minus 10 squared plus 10. Humor me and show that square root squared is free. And then you can go ahead and show that and do a check. Just arrowing up there for the work. So I do get x. So it works. And then I guess over to the right, since this is weirdly in the middle, I got to do k of h of x and prove that that equals x. H of x is x squared plus 10. And then k of that means, grab the highlighter, don't go too fast, Mr. Sanders. Wherever there's an x, throw in x squared plus 10. Guess I'll highlight that again. Doink. And then square root minus 10. Okay, 10 minus 10 equals that, and then x squared square root equals x, and then put a check. Doink. Okay, so it's all that algebra work. We're telling you it's an inverse. They are inverses, I mean, so you have to prove it. Do that work. Same for the last one. And then notice why. Can't have x equal 0. Can't have x equaling 4. So that's why they throw those conditions in there. Just making sure. Oh, boy. N. I'm going to do a capital N of P of N. X, sorry. P of x is 6 over x plus 4. Okay. So, wherever there is an x in the n function, I got to put 6 over x plus 4. Oh, no. So I got to put 6 over x plus 4 minus 4. And I'll grab that highlighter again so we could see that. Because I made a mistake last hour. And it was probably because I didn't do the highlighter. I double saw a number and made a mistake. All right. Oh, what's minus 4 plus 4? That's nice. Minus 4 plus 4. Cancel. 0. And then what's 6 over x? What operation is this? What operation is that? What operation is that? Division. So the very next thing we should be able to write is 6 times what? X over 6. The old flipping of the second thing when you divide. Then you could cancel and you could say check baby, 1, 2, 3. It's actually really simple math there. Fortunately, in your homework, there is one that's a little bit more of a challenge. I'm going to see if you're up to the challenge, and then we could discuss it tomorrow. All right, but we'll see then. So I did n of p of x, right? Now it's p of n of x. Capital, just because. N of x is that fractional thing, 6 over x minus 4. Oh, good thing I didn't make a movie last hour because I screwed this one up. I'll show you what I did. I actually double saw a number. All right. So wherever there is an x, I must plug in 6 over x minus 4. This is what I wrote last hour. I accidentally, I saw the 6, then I didn't write it again. So I'm just admitting my mistake. And the highlighter will show me why, or that I did the right thing. So highlighter here, highlighter here. Okay, I got everything now. X turns into all of that 6 over x minus 4. Okay, yet again, what does it mean to do 6 divided by 6 over x minus 4? 6 times, everyone say it. Nobody does. X minus 4 what? Over 6. And then you are allowed to cancel those 6's. And then you do get x minus 4 plus 4, which is what? X. Check, baby, 1, 2, 3. All right. We done. I don't want to do anything else. You can run into that challenging one and see if you're up to it on the home.